Key concepts in Unit 2 include that the atom is the smallest individual unit of any element, and an atom consists of a nucleus which contains protons and neutrons and of orbiting clouds of electrons. So you can see here is an atom of beryllium. It has 4 protons and some neutrons in its nucleus. Then it has 4 electrons surrounding. Here's lithium right here. It has 3 protons, has some neutrons in the nucleus, and then 3 electrons surrounding. The atomic number of an atom is equal to the number of protons in the nucleus. So atomic number is the number of protons. So here beryllium has an atomic number of 4. You can physically count 4 protons. 1, 2, 3, 4. Protons are the ones with the plus signs on them. Lithium has an atomic number of 3. It has 1, 2, 3 protons in its nucleus. And in an electrically neutral atom, the number of protons is the same as the number of electrons. So here is neutral beryllium, 4 protons, 1, 2, 3, 4, 4 electrons, 1, 2, 3, 4. Same thing with lithium, 3 protons, 1, 2, 3, 3 electrons, 1, 2, 3. Atoms that carry a positive or a negative charge are called ions. So these are not electrically neutral, and they will have different numbers of protons and electrons. So this is a neutral atom right here, a neutral atom of carbon. It has 6 protons and 6 neutrons and 6 electrons. Neutrons have nothing to do with ions. It's really the numbers of protons and electrons that matter. This atom right here is negatively charged. It has 5 protons and 6 electrons. So it carries a charge of -1 because it has 1 more electron or 1 more negative charge than it does positive charges. This atom right here is positively charged. It has more protons than electrons. It has 6 protons and 5 electrons, and it would have an overall charge of +1. Just a reminder, in a neutral atom, if it loses electrons, it becomes a cation and becomes positive. If a neutral atom gains electrons, it becomes an anion and becomes negative. Isotopes of an element have the same number of protons, but a different number of neutrons. So isotopes of an element have the same atomic number, but different mass numbers. So here are 3 isotopes of carbon. This is carbon-12. It has 6 protons and 6 neutrons. This is carbon-13. It still has 6 protons, but it has 7 neutrons. And then this is carbon-14. It has 6 protons and 8 neutrons. So you'll notice all isotopes of carbon, and actually all ions of carbon as well, have 6 protons. Having 6 protons is what makes something carbon. So the number of protons never change. If the number of electrons change, it becomes an ion. If the number of neutrons change, then we're talking about isotopes. And then I should mention, this number right here is the mass. You'll see it written as carbon-12. That number's the mass number. What is the mass number? Well, the mass number of an atom is equal to the number of protons plus the number of neutrons in that atom. So literally all you do to find a mass number is count up the number of neutrons or look in the problem to see what the number of neutrons are, add to that the number of protons. That will give you the mass number. For example, carbon has a mass number of 12. You can physically count in here. Neutrons are blue. There's 6 of them. 1, 2, 3, 4, 5, 6. Protons are yellow. There's 6 of those. 1, 2, 3, 4, 5, 6. 6 and 6 is 12. That gives you the mass number. Protons and neutrons have an equal mass. Electrons are so tiny compared to them that you don't even count them for the mass. If you guys want to pause right here and review, this chart pretty much sums up everything I just talked about. And now I'm going to do 3 example problems for you guys. So given an element's atomic number and or mass number, you can determine number of protons, neutrons, and electrons. So an example of something you might see on the midterm, osmium has an atomic number of 76 and atomic mass of 190. How many protons, neutrons, and electrons are in an osmium atom? Well, the atomic number of 76, that is the number of protons, so that's pretty easy. You could just write in 76 for number of protons. For atomic mass, they give that to you, that's 190. That's not anything that question's asking for, but you need to use that to get the number of neutrons. So we know that protons plus neutrons give us atomic mass. So 76, I'm putting that in for protons. I'm putting X in for neutrons because I don't know that. And I'm putting 190 in for atomic mass. So just solve for X here, and you should get 114. That means that there are 114 neutrons. Since we're talking about a neutral atom of osmium, they don't mention anything about having a charge. Protons and electrons will be equal, so 76. The next problem has to do with ions. How many electrons are in a chlorine ion? Chlorine ions have a charge of -1. So to do this, figure out the number of protons. That's the atomic number. It's the number that you see listed right above chlorine on the periodic table. So that's 17. -1 means that it has one more electron than it does protons. So one more than 17 would be 18. I know it seems weird because it says -1, so you're probably going to want to subtract, but don't do that. You actually want to add 1 because electrons are negatively charged. So it would have 18 electrons and 17 protons. And then the last type of question, number of neutrons, is the difference between the mass number and the atomic number. So how many neutrons are in carbon-14? Well, if you look on the periodic table, carbon has an atomic number of 6. That means it has 6 protons. So C-14, that 14 is the mass. So what you want to do is set up the equation mass is equal to protons plus neutrons. 14 is equal to 6 plus X. Subtract 6 from both sides, and you'll get X is equal to 8 neutrons.